This conference will now be recorded.
Okay, right. So my name is Clare. Brint. I will know some of you that have dialed in. I'm really pleased to have been asked to do this. I do tend to get very excited about railway earthworks. So my background, for those who don't know me, is I'm a geologist. I did my degree 25 years ago, probably. I've worked for about 10 years with a company called Donaldson Associates. Now they're Covey now. They do lots of tunneling work, but when I started with them in Scotland 20 years ago, we were doing a lot of railway earthworks inspections, and I did a lot of rock slope designs and inspections as well. So that's kind of my background. I ended up with Network Rail then after the financial crash, probably I guess 11 years ago, working with the Earthworks team in New York, and I've enjoyed it so much I'm still here. So that's my background. The team that I manage, we're the asset management team looking after all geotechnical assets in what is now East Coast, North and East, and East Midlands. So what was the old L&E and East Midlands route. We're currently a team of 11 people plus myself, plus some year in industry students and grads. We manage nearly 50,000 earthworks assets between us. It's worth pointing out that we carry out our own inspections and maintenance using contractors. So it's a bit different to what, say, the P-Way or other asset groups would be used to. So we use Amy for our examinations, and then we have contractors with works delivery who do kind of maintenance activities, refurbishment. So lighter than renewals type work, but they also do some of the larger reactive works that we do. And so the contractors we have with works delivery are mainly QTS, CML, and AMCO. Then with capital delivery, who they deliver our renewals work bank, and that's Story do that with us. So that was me. So what are the risks that we're trying to manage? Some of you will be familiar with some of these images down the bottom. So the bottom left is Clare Tunnel, a landslide that happened. A train, I think the train derailed as it was coming out of the tunnel, and that was, I think, 2012. The one in the middle is the one that was just mentioned at Corby, Pengreen at Corby. I mentioned that a bit. I don't go into the technical details of it in this particular presentation. So that's the one in the middle, and then the one on the right-hand side is the derailment of a freight train at Barrow-on-Soar, which happened as, I think it was 2013 or possibly 2014 on Boxing Day, or the day after Boxing Day, maybe. So those are the kind of incidents that we're trying to prevent and the risks we're trying to manage. So the table you see here shows the kind of the overall national figures. So for those who might not be aware or need a refresher, a control period is a number of years. It's either 4 or it's 5 years these days that we are funded for. So the data since privatization. So the first 2 control periods, we weren't collecting specific earthwork failure data, and that started properly in control period 3, so starting from about 2004. So we've got all earthworks failures. We go from having 477 noted or recorded in CP3 through to we've currently got 251. We had a lot last year. So that's the total earthworks failures. It's worth noting that those failures can include anything from like a reasonably small rock fall that might happen remote to the track, right up to any of the examples of the ones you see below. So it's quite a wide range of risks that you might be, or incidents you might be talking about there. The column in the middle shows the numbers of embankment failures. And then we've got potentially high consequence earthwork failures. So you can see overall that seems to be reducing. We had a lot of failures last year. There's still quite a lot of analysis to do on on that. Earthwork attributable derailments has reduced, as you can see there. So those are the kind of failures we're trying to deal with. Just some examples of the types of things you might have in an embankment. Top left, we've got rabbits causing pretty significant deterioration in the embankment. The troughing route is affected, and it's likely that the track is as well here. Then in top middle, you can see right next to a previous repair, you can see another failure has occurred here. It looks like it's earth flow, where possibly water has built up the other side of the railway and kind of saturated the ground of the embankment, causing it to flow out. Then top right looks like a rotational failure of an embankment. Bottom left is scour of a bank side, causing the wall to fail, and then also meaning it's not supporting the ballast shoulder anymore. And then bottom right is a washout at the interface between a cutting, which is to the right of the photograph. Normally I would be able to point and use my hands to show you what I'm talking about, but hopefully you'll get that. So the water came through the cutting and washed out that embankment. Again, I think that was 2012. So those are kind of those examples. We've got some cutting failures, the kind of examples I've got here. The one on the left-hand side shows a rock cutting just outside of Clare Cross Tunnel. And you can make out that there are some blocks in the 6 foot and some blocks in the cess. And for those who may be familiar with looking at rock cuttings, you can see that there's kind of a gap in the and an overhang, which it looks like that's where the blocks have come from. That's that one. Then the one in the middle again is actually Clare. We've already looked at it at that from a different view. You can see there's a lot of water involved in that one. Top right is a hillside, and so it's a natural slope failure, which started encroaching on the railway. And bottom left, that's a tree stump that actually came down at Clare. Lots of photos of Clare. So that's safe. Those are safety risks. Obviously, when you have a safety incident, that will obviously affect performance. But there are other issues around performance that maybe we can manage the safety of it, but it affects the performance. So just to remind people about how we measure performance. It combines figures for punctuality, reliability into a single performance measure. And I took this from the website today. So the kind of things that performance impact can be down to that would be part of my world would be extreme weather and then network rail infrastructure. So these two definitions here. So when you have extreme weather, that would be exceptional weather conditions beyond our infrastructure design. So typically storm winds could affect us. The site that was mentioned earlier at Drax, for instance, that was an embankment running through a flood cell. The area around it flooded hugely through February. It was flooded for days and days, but it was flooded during periods of very high wind, and so that caused waves in the bankside, actually causing erosion in the bankside. So that's extreme weather. And then there's network rail causes here, which is to do with failure of our infrastructure. So that's where an embankment may start settling. We can manage it by putting a speed restriction on, like this example here, but the performance impact needs to be managed by my team. So this particular example I'm showing you here is one at a place called, with the great name of Brockley Winds, which is up near Sunderland. And I'm sure everybody can make out the track fault there. That was from about a year and a half ago or so. We've spent about the best part of a year trying to fix the big embankment below it. I have a photograph later on in the slideshow showing you what that looks like once we fixed it. But those are the kind of performance impacts that you can manage the safety impact, but it's quite a lot of delay minutes you get from that. So the next part, what that I want to define for you, because I think it's always useful to go back to definitions, is what do we mean by railway earthwork? So, and how do you manage an asset, which can be really quite diverse. So the first image is just from GeoRhythm, our mapping tool, and it shows you looking straight down. You can see what we know is a cutting on the left-hand side, and embankment on the right. So this is from the LiDAR images that we have available to us. And if you think about, okay, you've got these as your assets, how do you manage them? What do you do? How do you count the condition? How do you compare one asset with another? So if you look at that, so would you say that's the asset? Would you say that there's two separate assets there? Would you say, for instance, that's the whole asset? So it's quite difficult to be able to compare like with like there. So the decision was taken when we were working out how to understand and manage our assets, that we would split them into what we call 5 chain lengths. So that's 100 meters, 110 yards. We look at them on each of the sides of the railway, and we carry out inspections and gather data on each one of those kind of elements of a whole earthwork, if you like. And that allows us to gather data, to manage inspections, and to manage any work going forward. So that's what we do with those. And this shows you here that how it's split up. So you would go out and do an examination on one of those coloured bits there, and that would be considered the asset. So when I said earlier we've got nearly 50,000 assets, that's what I'm referring to. So what is Earthworks Asset Management? We've got an Earthworks manual, a management of Earthworks manual, a standard that we work to. We've got an examination of Earthworks manual, and we've got a series of modules that sit kind of within or next to this, which help us manage the risks from our earthworks. In my team in York, we've got this, what I refer to as our kind of team plan. It's a very high level look at what are we here for and how do we do what we're here for. So just zooming in there, I've got a team vision. So my vision is that we will fully understand the risks from our earthworks assets, and we will mitigate those risks using the best tools and resources, and ultimately provide a safe and reliable railway. And then in terms of our mission statement, we'll predict, prevent and respond to failures in essence. So the idea is that our job is to be able to predict where failures may occur, and we should be able to do that through our asset knowledge, through our programs of examinations, valuations, monitoring and assessment. And then we'll prevent failures from affecting safety or performance through the monitoring, maintenance, refurbishment and renewals work. And then thirdly, responding to failures as they occur, providing technical and practical support to the operational teams to help minimize safety risk and performance impacts. So that's kind of, from my point of view, I keep coming back to this to say, is this what we're doing? Is any work we're attempting to do actually, is it tied back to this? So yeah, so this bit, well, I'll look at the prediction side of things. So in the last few years, a couple of years, we've been really trying to work at improving what we do and how we do it. So we have been kind of doing process maps, mapping out what we do now and how we do it now, and identifying where there's gaps in either individual processes or how we do things, etc. And this is kind of what you're looking at here. I don't expect you to be able to read all of this, but this kind of maps out what we do from, on the left-hand side, having an examination, planning an examination, carrying out an examination, deciding if you need to evaluate it, deciding if you need work to be done, how you get it into a work bank, how you write the remit for the work, how you work out how you're going to fund it, which deliverer will deliver it for you, what kind of time periods you need it doing in, and then actually carrying out the work, and then doing the handback bit, and then the follow-up and updating asset information, etc. So we've been mapping this out. It ties in with what's in the standards, but we're turning it into something that works for us and makes sense for our team. So you'll see there's little notes next to each of it, and these are all the individual bits that we know we've got to, write guidance notes for, or process. It might need its own little process map. So I'm quite excited about this and the work we've been doing to make this better. So again, just to remind people what an earthworks examination is. So you have to imagine somebody in orange, they're probably a geologist or a civil engineer by background. They tend to like being outside in the rain and the damp and in the hills, and they will go out and spend all day walking up and down our earthwork assets on our behalf. They'll have a handheld device where they answer a series of questions, and on the back of the answers that they give, there will be an earthworks condition score, or an earthworks hazard category rather, will be the output of that. So an A, for instance, I may have mentioned this already, an A is the statistically least likely to fail, while a D or an E is statistically most likely to fail. So you can see the kind of questions that they would answer while they're stomping up and down our earthworks assets. Is they will look at the form of the earthwork, what the geomorphology looks like, if there's any track movements, if they can see any evidence of any track issues, if there's any leaning trees or structures. So if there's bent tree trunks or they're tilted, that would be noted. If there's any cracking in the slope or movement, history of instability, animal activity, like the rabbit evidence we saw earlier. Those are the kind of questions that they answer. And then they'll also specifically look at individual types of failures and take photographs and make notes on those, again, on our behalf. So that's the first thing that happens when you get, if you get a new 5-chain asset that comes out as a D or an E, that is required to be what we call an evaluation is needed to be carried out. Other reasons that you might carry out an evaluation is, for instance, if one of our neighbours came to us and said, my fence is leaning and I think your slope is failing, we would carry out an evaluation. You might, if the maintainer came to us and said, I'm having problems with the track, I'm losing the ballast shoulder, again, that would need an evaluation. So as part of an evaluation, we would obviously look at the history that we can find in the examination reports. We look at our own local files. We've got a series of historic files from the 1960s on that soil mechanics did, and I've got a couple of examples of that a bit later in the thing. We also would look at LADs, so look at the track quality information, see if there's anything evident there. We talk to drainage. If there's a retaining wall there, we might look at that. So those are the kind of things that we would look at and decide what we want to do next. So I've got an example of a site here which is so this one has a little bit of history with it. So there was a track fault, and my colleague, must be about 10 years ago or so, he went out in response to being told about a track fault, and it was at Riding Mill. And when he went out, he found during this, the evaluation of the site, he found that there had been history from about 10 years before where a previous repair had taken place. So you can see there it says reconstruction of the railway embankment, which slipped in adverse weather in the River Tyne near Riding Mill. So it shows a little as-built drawing that we had in our scanned files, and it's got a little photo there. So he found that. He was aware that there was still a track fault, so being suspicious that maybe this work hadn't actually, properly repaired it, he installed some inclinometers. So an inclinometer is a borehole driven into the ground or drilled into the ground, and you put a plastic tube, and then you're able to drop an instrument down the plastic tube at regular intervals, and you can see over a period of time what depth movement might have taken place. So he had those installed. Then in 2016, we had more evidence that the embankment was starting to slip. So you should be able to make out there the white paint marks, spray paint, which is showing where the cracking is starting to happen. And then you can see the blue kind of head pieces from the boreholes that were already installed. So we were able to use the information from those boreholes to be able to understand and actually carry out an assessment very quickly. So this is what an assessment might look like, slope stability assessment, and that allowed us to design a new repair, and I think we installed a bit more, some more monitoring in there to be sure that the repair was working. So that's kind of, those are some of the options that we might do on the back of an evaluation. This is one of the things that is one of my close to my heart, the idea of moving our team towards a place where we will be managing whole earthworks, if you like. So we've got the detailed information for each of the individual 5 chain lengths, but I want us to get to a point where we understand each of those, the whole earthworks, that we use those kind of building blocks of earthworks exams, and all of the extra kind of evaluation information and desk study information, that we gather all that together, so that when something happens in a site, we really understand the site. So that's kind of one of my, we're working on this. That's that one. Oh yeah, coming back to my team plan. So preventing failures from affecting safety or performance. Here I've just got a couple of examples here of, oh yeah, I came back to this. Oh yeah, sorry. So within this asset management system overview, we've just looked at the bit where we've got an exam, an evaluation, and works being required, the kind of the bits in between that. We're now looking at, what am I looking at? Oh, this is the monitoring program, yeah. So kind of, you're still in there where you might not be really sure what work is actually required. So the image we're looking at there is a cross section through a slip that happened last week, actually, and these are old slip indicators. You just have to imagine that I've given you a more modern one, which has proper more modern boreholes in. So the slip indicators were these again, small alkathene tubes that were driven into an earthwork, and similar to what we do now, slightly less advanced, I guess. And those allowed the earthworks section at the time to be able to measure again where the ground was moving. So as part of our monitoring program, we have about 80 to 100 sites across our routes where we have these kind of instruments in, and we review and monitor the data, the information that comes back from them, to help us understand if we need to do some, if we need to instruct work. So the table sitting behind was just really an example to show you some of those sites and the frequency that those embankments might be on, and the kind of, we've got NRDD on our behalf have been carrying out detailed reviews for us, which has been really, really useful, and they've been providing us with recommendations and yeah, really, really adding value to that. So that is some of the monitoring stuff. And then here's just some photos of earthworks renewals. So top left is, you can just make out the size of the thing you're looking at by the person standing behind the drilling rig. That is at a place called Peckfield Cutting. And they're installing drill holes for rock netting that's being installed there. Bottom left is a site at Barkston, which was a track fault site on the East Coast Main Line. So the embankment built there will hopefully prevent future track faults. The two images on the right are from a Hartley embankment where we installed cess restraint, and then you can see where when they've put in the fence so people don't fall off the edge. Then this is a photograph of the site I mentioned earlier at Brockley Winds up near Sunderland, and it is a very big slope. Yeah, we ended up having to build out the culvert in order to be able to shore up the embankment, and just so in between the So you've got the railway up the top left with the stanchions, and then there's a smallish embankment that comes down onto a roadway, and then the rest of the embankment coming down. And yeah, that's just finished on site last month or so. Now we're into responding to failures as they occur, providing technical and practical support to the operational teams to minimize safety risk and performance impact. So I've got 3 examples of sites where we reasonably recently we've kind of helped manage the incident. So this is only a few slides really. This one at Corby Pen Green, I'm not looking at the technical reasons for the failure or anything. It's more about what we did in those first kind of 24 hours or so to help manage the incident. So we as soon as we were aware of the incident, our contractors, CML, who are our on-call contractor, went out to site and they carried out work on the kind of the river, the stream above the railway, clearing out a lot of material, which improved the situation straight away. But they also helped with getting the people off the trains, which is what you're seeing there on that right-hand image. This is the bit that I thought might be interesting for people. So our examiners, so we're a reasonably small team. We're based in York and we cover a very big area. And as I say, we carry out our own inspections and maintenance. So on our behalf, Amy provide an on-call response. So when an incident happens, they will go and visit the landslip, and they will provide a report to us, and they'll liaise with ourselves so that we can understand what's going on. So they were able to provide all these photographs you're seeing here, which helped those of us sitting in the office remote from the actual incident build up a really good picture of what was going on, technically what had happened. And that it just means that the communication around the incident can be much smoother. So that's that. And there's our contractor on site digging out, starting to get ready to install the repair on the site. So then this one is a site at Weatherall, which happened last October. And as you can see there, we had a landslip which stopped trains on this. It was following a period of extremely heavy rainfall and localized flooding, and that landslide, it was a 5-meter high soil cutting. It's as you see, it's Weatherall on the Newcastle to Carlisle railway, nearly as far as Carlisle. In fact, we stopped both lines for that. It was only I say it was about 5 meters wide and about the lower 2/3 of the slope which slipped. During that day, we removed the slip material. We got ballast bags put in place along the toe as temporary protection, and then we reopened the line the same evening while we continued works to complete the permanent repair, which was stone fill. So I've got some more photos here. So this is a plan looking down, an aerial image. So you can see there's a farm and a farm track directly above it. And for the eagle-eyed amongst you, you might notice that from the left-hand side, there's a blue line, which is indicating a stream of some form. So that's what you can see there. Again, I thought this would be interesting for people. So our latest examination at that location had been in December 2018. And the examiner took this photo here. So you can see, I've matched the two so that you can see kind of what it looked like after the slip and what it looked like before. The green moss indicates that there probably is water coming through that slope on a regular basis. But again, it hadn't been a site which we had been particularly aware of. So again, I've got a LiDAR image, and it just shows you the farm track there, the stream that's flowing south. So the stream isn't actually flowing towards the railway, but there's issues from a pipe in the area just above kind of the slip. There's a little cross section showing you that we're able to get from the LiDAR. in GeoRhythm, which is always quite fun to be able to see. Oh yeah, so this shows you what was going on with the water at this site. And again, we were able to build up this picture from our contractor being on site and being able to feed back to us what they were seeing, which allowed us to really try, understand what was going on. So the surface water flows were flowing up that farm track, and then they ended up ponding up behind the cutting, causing the slip. So here, this is it. So the farm track was knee deep in water when the contractor arrived. We think what was going on was that there was water soaking through the ground and exiting out of the slope face through the sandy layers. It was reported that there was a back scar with groundwater springing from the sandy layer. There was also evidence of overland flow of surface water, and you can see the sandy seepage there as well. Quite like this slide. Okay. And then this is the temporary repair with the ballast bags, and then the contractor continued fixing it while the line was reopened. So that's kind of one of the ways that we try and make sure we get the railway recovered and trains back running as quickly as possible and safely. Then this one is the most recent slip. This has just happened last Friday. We were first told about it. So yeah, it was Friday afternoon. It was reported by the local maintenance team as erosion of ballast shoulder. The embankment is near Frodingham Viaduct in Scunthorpe on the Dow line, near the 21.5 mile post. So I think it's just along. If anybody knows Frodingham Viaduct, it's just along from there. So at that stage, an emergency speed restriction was imposed, and following visit by our contractor and an AME examiner, it was decided we would keep that ESR of 5 miles an hour in place and put a watch person in place until further notice. So the ballast continued to erode over the weekend, in particular in response to freight trains going over it, and it was decided to stop all traffic on the down line by Sunday the 14th of June. So the embankment is very steep and heavily vegetated. So you can see some of the in this image here, you can see the dense vegetation here, and you could probably just make out the road below, which is called Brumby Lane. So we found that there was some history here. So we have, it's quite evident in the LiDAR image. So you can see at the toe of this slope, you can see the kind of an old berm repair here, which we believe from our first kind of go through, this is all hot off the press, by the way, from our first go through of the old soil mechanics files, that is the slip that happened in 1946. There is also, you can make out from the LiDAR that there's kind of what looks like possibly berm or something along the toe as well for the rest of the length of it. And there's evidence of, I think what we call bulldog of boulders, which are used at the toe of the slope, presumably to try and shore it up. And then in the 1980s, there was a slip reported. I think it was first reported in 1973, where they did some ground investigation, and then they grouted it up in 1981. So you can see it's not exactly at the same location as our new slip, but obviously the embankment doesn't look as if it's in great nick. So, oh yeah, there. So you can see that the ballast shoulder is getting very close to the 300 mil, which was the limit that was set for closing the line anyway. So in our little cross section, I've done a likely surface failure. We're not really sure about that for certain yet. But the next image, the one I showed you earlier, as well, it's kind of likely to be something like that. We've installed monitoring at the site. We, as I say, stopped all traffic on Sunday on that line. We've now stopped all traffic on both lines so that we can get the piles installed as quickly as possible. So they're going to be working 24/7 to get the piles installed so that we can reopen the line, and then we'll work on the whatever other repair is needed below those piles. whether that takes the form of a stone berm or anchors or something. We're still working that through. This was the one I mentioned earlier. So this is a cross section through the downside embankment at the area where they grouted back in 1981, and it just shows you at that stage the shape of the slip there looks like this, with the toe of the slip coming out above the toe of the slope. But we'll be working on that ground model over the coming while. So those were my 3 examples of slips that happen and the work that my team do to try and our contractors and suppliers do to try and get the railway reopened as quickly and as safely as possible. So for the last little section, I just want to talk about some of the continuous improvement stuff that we're doing. The first one I mentioned earlier about the management of whole earthworks. So that's continues to be a work in progress. The other thing that we're doing, which I think is going to make a big difference to how we manage things, is that we're creating separate maintenance and renewals teams. To date, our teams, the senior asset engineers and the asset engineers, have been responsible for the kind of day-to-day maintenance and responding to queries and dealing with neighbours, etc. at the same time as they're, trying to understand a historic problem, write a remit for a £1 million job, and manage that, the delivery of that with our deliverers. And it's not really, you can't do both of those things at the same time. If you get a call from control, you have to drop everything and deal with what's happening on the ground. So we're moving to having separate teams and separate processes as well, which I think will really help. So then the last 3 things are some of the stuff we're doing around improving our kind of responses to incidents. So developing a potential TSR register and actively managing that alongside our track colleagues. There's the landslide detection alert systems, which is underway at the moment, and then locally we have kind of changed up and improved how we prepare for and respond to adverse weather as well. So I'll just talk about these 3. So potential TSR list, the idea is that our team will have a register of all of our locations that we're worried about, and that we have a management plan for those, and that we review those on a regular basis. So it might include things like, some stuff that's on our adverse weather list. It might include some of the hot weather sites potentially that track deal with year by year. It could include sites that are going into our renewals work bank for the future, some of these monitoring locations we looked at earlier, and then some of the clay desiccation sites as well that we get in those clay banks in the south of the route, region rather. So then the landslip detection trial. So these are the system. It's got 2 banks of wireless till sensors, and they're spaced 2.5 meters apart. We've got a centrally mounted pole, logger, cameras, etc. And then the till sensor data is sent back to control, where if there's alerts or alarms generated, they come via text and email. They've got camera images as well, and the intention is that it will help us help prevent trains encountering a landslide. So if the embankment, if the cutting starts to move, we'll be able to tell quite quickly and be able to stop trains. That's the intention of it. So we're going through the trial for that at the moment. Here's an example. So if you're out and about and you see things like this, these yellow sticks, basically, that's what you're looking at. They generate alarms, as I said, directly to control, and the alarm can cause trains to be cautioned. And for those of you who might be out and about trackside, please don't interfere with the site structure or equipment without speaking to control first. Don't hang your coat on the poles, and there should be contact details next to it. And that's that. And then, so in terms of our adverse weather and what we've changed in the last year or so, is We used to, it depend on the local maintenance teams to visit our sites that we were concerned about. So we've got a list of earthworks sites that we're able to, that individually get forecast for rain against them. So the ones you're looking at red are forecasting very heavy rain, basically. And we used to go on the EWAT with control and the local maintenance teams, and we, would give them the list of sites and hope that they would be able to visit them. And people really struggled with that, because if it was a high rainfall time, they were probably off visiting a number of other flooding sites, or they might not be able to get to it, or they had a limited resource. And so thinking about the fact that we are our own maintainer, and we have contractors who are know our earthworks assets really well, we've moved it so that we're now using them to do those visits on our behalf. So this is an example of a period of adverse weather where we identified these specific locations. It includes Corby Pen Green, for example, and the table that we will send out to our contractor will give each of these locations. It'll say what the risk is, and there'll be specific remits to go with each of these as well. So they've got a map and they know what they're looking for. But this kind of summarizes it. And then, so what we do is we raise a fault with control for each of those sites to be visited, and then they go out to visit it and they provide us a report with photographs and recommendations, etc. One of the issues previously by using the local maintenance teams was we kind of missed that feedback loop where we would get information back into our systems, whereas with this, it really does help us understand a site better. So this is one example where that's been very effective on the Newcastle Carlisle line. Frequently, you would get the line being stopped due to water coming down these at these culverts. So it's a natural, in that image you're looking at there on the left hand side is a natural slope, natural hillside, and then on the right hand side it's the River Tyne, and that natural hillside has a series of streams coming down it and coming under the railway in culverts, and they often get blocked because they bring a lot of debris with them. So they get blocked up, and you end up with the trains being stopped due to landslips. So we've been sending our contractors out, and they've been clearing them up in advance, and it has been working really well, and been able to feed back into our asset management systems. And that's the end. Are there any questions?
I have a couple of questions. The first one is from Bill Free. I am surprised to see how you define an asset. I would have expected you to be considering a cutting or an embankment as a whole asset, since a lot of the issues along any given cutting or fill will be similar.
Yes, I mean, I guess that's true. When you're trying to manage the assets and when you're trying to understand the data, I can understand why we've chosen to do them in these chunks, but they are just, as you pointed out, they are just building blocks of the whole asset, and that's why I'm kind of trying to move us towards a place where we are managing it from a kind of whole asset perspective. I think Simon Abbott said he would be on the call and may or may not want to comment on that. If you decide to, Simon, you can put your hand up, I guess. I hope that answers that question. I think it's a reasonable point.
Yes, because Bill did actually come back subsequently about it. But my next question that I've received is from Paul McCune. How do you categorize the condition of an earthwork if partially or wholly covered in dense vegetation?
That also is a good question. So we've got guidance in our standard about where we should be taking vegetation off in order to carry out an inspection. So what we do is we can do strips of, so we do a strip, as far as I remember, it's 1 metre wide. It might be 1.5 metres wide. Where if the examiner says, you know, I can't see enough here to do it, to do a full examination, then we'll send our contractor out separately to do strips of vegetation management. So you'll clear a strip from toe to crest, and then you'll also clear a strip along the toe or the crest as well, so that you can see if there's any issues along there. So that's what we do. There's guidance in our standard for doing that. And as I say, we'll either do strips of from memory, I think you do probably 3 or 4 strips along the 5-chain length in order to be able to get a good feel for it. But we also sometimes will just take all of the low-lying vegetation off so that we can see it. Again, hope I answered that question for you.
Okay. Can we now open the line to those who are using phones, and if they'd like to answer or ask their questions directly with from an unmuted mic, if there are any?
We actually don't have any callers on the line today, Kevin. So.
Okay, all right. Well, in that case then, seeing as we don't appear to have any more questions, which was a little bit...
question, Kevin?
Yeah,
sorry. It was a quick one. Firstly, thanks, Claire. It's very informative, very useful, and I do like lots of pictures, so some excellent examples in there. It's Brian Whitney here from Track at Milton Keynes. One of the questions I had was, do you use sort of some of the historic records as a means of identifying at-risk sites? I noticed a number of the examples you put up there seem to have a somewhat checkered history, both from a track maintenance point of view or some more significant earthworks failures, but I wonder whether that was a useful
absolutely it definitely
there, as whether that sort of finding historic records when you're looking stuff back 50, 100 years, how reliable that is, or whether that's a helpful thing.
So no, they do really help. I mean, for instance, the ground investigation, which, you know, was from 1973 and 1980, the ground model that they did from back then helped us in being able to do a really quick design to facilitate the contractor. So we had the design, so the slip happened on the Friday, our designer went out on Saturday, we dug out all the records, you know, between Friday and Saturday, we dug out the records and downloaded them from the scanned versions. We were able to kind of look through those, provide them to the designer, who by Monday was able to, they used those as well as the information from their site visitors. They were able to use that information to build a reasonably basic and kind of worst case scenario, if you like, ground model. But then that allowed them to design the length of the piles so the contractor could get those materials ordered by Monday afternoon, so we could be getting them in the ground this morning. To really minimise the amount of time that the railway was going to be shut. So that historic information is really, really useful. I think part of your question was around, can we use it in advance of an incident happening? And that's part of what I'm trying to do. Yeah, so that's what part of what I'm trying to do with the Earthworks management plans, that we build this picture of a whole earthwork by digging into that history first before we get an incident happening, so that we can say, right, okay, do you know what? We know there's a history of like 3 slips in the last 60 years there. We should be putting ground investigation in. We should be potentially examining it on a more frequent basis and planning to do a renewal in maybe CP7 or something, but that we can be building up that kind of a work bank of sites that need renewal based on that intelligence, rather than waiting like we did at this site where the slip happened.
No, thank you for that. Just having ground models, or do you have ground models for sort of at-risk locations, or is it just when sort of incidents occur? I was just thinking whether that, again, it seems to be a very useful thing to have in your back pocket almost when something does occur, to understand what you can do to rectify it.
Yeah, so we do, and like for instance that site at Riding Mill, we did have ground investigation information again that we had done, but it tends to, the information we've got today does tend to be in response to either an incident or being told about something. One
Yeah.
of the things which I didn't mention earlier, but which is in, I'll see if I can find it because it's probably worth looking at. It's in my Earthworks Management Plan, and it is in here, right? So we've got something called the GSRA, Global Stability and Resilience Assessment, and it's something that Milton Keynes kicked off on our behalf. And what this has done, it's like I can't remember if it's like a level 0 assessment of each earthwork, and it uses the LiDAR information, the angles and the height data, using the geology, the geological information. So you can kind of have a very simple ground model using that, knowing either what geology it's cut and a cutting is cut through, or the most likely geology that the embankment was built on, depending on how close it was to a nearest cutting. And that is, we're using those as kind of a part of our desk studies, and when we're doing these earthworks management plans, I think there's a lot more we can do with those to build them into what we do. So again, I hope I answered that question. I may have rambled a little.
Thank you. And the last little bit, if there's a time, Kevin, apologies. The LiDAR looks, certainly the terrain models appear to show some very useful information in those. Is that something you'd see as a routine inspection, perhaps, going forward to look at changes? Certainly some of the sort of toe bulge and start of rotational slip seems to be evident in some of the LiDAR images you showed.
Yeah, yeah. So I think that is being looked at. There's at least one project underway kind of looking to see if you can compare LiDAR information from one period to another to see if it shows evidence. I think the jury's out on that at the moment, but it's definitely worth certainly when you know there's an issue, or in the case of where you're doing an earthworks management plan in advance of an incident happening, you can look at different. That's a good question. I assume that on GeoRINM you can look at the first version of LiDAR versus the newer version of LiDAR. That's a question I must ask.
I need to go and have a play. But yes, fascinating. Thank you. And thanks for the presentation. Appreciate that.
Thank you.
Kevin, can I come in, please? I did send in it's Andy Savage here.
Oh, right. I haven't seen it. Kate's just asked me, have I seen some of the latest questions? And no, I haven't. So I don't know whether I've missed any or not.
Right, well, you've missed one from me, so if I may. Hi, Claire, it's Andy Savage here.
Hi.
Thanks for the presentation. It looks to me that the system is much more comprehensive than when I was back running divisions, which is a long time ago now. But do you think, if you go up to a high level view, that the number of slips is increasing or decreasing? And a subsidiary to that, is there any evidence that climate change is affecting the slip performance of our industry?
This is definitely where I wish Simon had stayed. So if we go to that first, I'm just going to, hang on, what have I done? Yeah, if I go to that first slide, should have just done Control Home, shouldn't I? There. So in here, so up to the year just gone, I would say that we would all be able to say that it does look like the numbers of earthwork failures are reducing. Like this one here says relatively stable, but this number here, 251, is for 1 year, the first year of CP6.
Yeah.
So it doesn't look great. You kind of think, okay, is that climate change? Yes, we have had a really, really wet year. And the assets are continuing to degrade. That they were built 150, 180 years ago. They would be life expired if you counted them that way. I think we are also better at recording the incidents now than we were before, and that may account for some of kind of that possible increase. And I think climate change is definitely will affect it. That you've got higher rainstorm events, more intense. You've got it's windier, colder, wetter. It will do. Again, I'm not sure I answered your question there.
It's very difficult. I know back in both Watford and South Wales days, we used to have a lot of slips, and even when I was at RAIB, there were a lot of slips as well that we investigated. But I have no feel at all as to whether the situation is any better or any worse than it was 30, 40 years ago.
Yes, I think,
Now-
yeah.
Go on,
Sorry,
Claire.
go on. Well, I was just going to say, I think this is definitely where I think that the work that STE, that Simon Abbott and his team are doing, where they're kind of looking at those overall numbers, they're definitely the people to answer those questions. I'll have a go, but I'm not as well informed as them.
Yes.
Can I ask whether there was anybody else who had sent to the organiser a written question that has not been found at the moment, or anybody else who would like to ask a question?
Hi there, Kevin. It's Andy Pack here. Yeah, I just sent a quick question in. Is soil nailing a technique you use very often these days to strengthen earthworks?
We haven't used soil nailing for quite a while. I think when I joined the team about 11 years ago, there was a couple of sites which were using soil nailing, but my experience remitting work and actually being part of teams getting remedial works done, we haven't been using them. No, I think they might in other regions or routes. I guess in L&E and East Midlands, or old L&E and East Midlands, we often tended to have more room, and so we would usually tend to regrade, either make a slope shallower and purchase land, or use stone fill. So we whereas I think in more densely urbanized areas, you don't have the land take, and so you have to do more novel things like possibly soil nailing.
Yeah, I was just interested because in the late 80s, I was at BR Research and we were doing some of the initial research on whether they'd work in a railway situation. I just wondered how it had got on over the years, that's all. Yeah.
Are there any other questions at the moment?
Kevin,
Yeah.
David Godley, I sent a question in. Can you hear me?
I can hear you,
Yes.
David, but again, that question didn't go. I haven't got the question, but I was going to hand over to you anyway to give your
No,
vote
don't
of
worry,
thanks.
Kevin.
So if you want, to
I don't
ask
want to
your
vote
question,
I want to ask
and
a
then
question.
give a vote of thanks.
I'll do a vote of thanks in a while, but are we short of time? There might be one or two other questions. My question is,
Yep.
Claire, you mentioned about alkavine tubes a couple of times, and you showed some old ones on one of your cross sections, the one I think you showed twice. And we used to use them quite a lot when I was doing this sort of thing with working for Andy Savage in Wales and Watford. But they weren't very effective. And I wondered, you said you got something better, which I think you also showed on your recent cross section. So I wondered what you could say about why do you have something that's better now? How is it better? Because I haven't seen it and I'm a bit detached from this sort of thing now.
Yes, sorry, I did think that it would be good if I got a decent photograph of it, and I never managed to. So you have to imagine, so alkavine tubes are kind of tend to be maybe 20 mil wide, something like that, and they're just a tube that's pushed into the ground, and then you put your a little, well, any kind of a weight down, and you measure where it stops going down, and that will show you where the slip has happened, for instance. And so all you're doing is finding where the ground has moved. The new instruments are bigger. They tend to be, obviously I'm using my hands now to try and describe this, which is no good to anyone. They're about maybe 500 mil across. I might be a bit off there. And the borehole is drilled. These tubes are installed, and you'll have bentonite grouting put around them. Then within the tube, you've got little, not grids, little, words are failing me. Anyway, so you've got that tube, it goes in, you put your instrument in, you put it to the bottom, and you take measurements every, maybe it might be every half a metre or something, and it tells you how much that has moved over time. And then you can build up a picture of where and how much movement is happening. Again, I wish I had an image to show you. it's hard to describe, but it gives you the main difference between the two is that it gives you you can find out if there is more than one depth of movement happening, and you can find out the rate of movement and how much movement has happened.
Thank you, Claire. I do understand, because those Alcathene tubes are a bit of a one-trick pony. That was the problem with them, but you've explained how the new system works much better. Yeah, thank you.
Okay.
Has anybody else got any
Kevin?
questions? Yes.
Kevin, I can see the questions. I don't know why they haven't come through to you, which is such a shame. But if I can ask you a question, Claire, on
Yes,
behalf
certainly.
of Stephen Long. The examples of failures we've seen are related with water and rainfall. Does ground movement due to drying out result in similar dramatic fast failures, or does this effect usually have a slower impact that is picked up in maintenance?
Yes, I think that the latter would be what would usually happen. So the clay embankments that tend to dry and suffer from what we call desiccation will be slow going, and usually I think that the problem with that is your bank dries out, you get a wobbly track, as I refer to it, but you get a track fault, and because it tends to be in hot weather, they can't tamp, and so you end up with speed restrictions on right through the summer once that's happened. And again, it's the embankment drying out rather than an actual failure. Usually you can get where you've got long periods of dry weather and then heavy rain like we've had recently, that can lead to failures. So you've got the ground drying out, you might get some cracking, etc., and then you've got water going into those cracks and potentially causing slips.
Thank you. We do have quite a few questions. Perhaps if we just limit it to another couple. One from Nick. Many thanks for the presentation. Are there any developments in using remote sensing techniques for inspection, potentially in SAR with permanent reflectors or regular LiDAR surveys using drones and hyperspectral imaging?
Yeah, there's some work going on that. The latter, the hyperspectral stuff, there's a project underway with, I think, the Highways Agency, looking at whether that could be useful or not. Putting on, so I think if you've got a site that you know is an issue, it can be really helpful. But when you look at all of the assets and the area that we need to cover, it's quite tricky to use it at this stage with the technology and the way of using that technology to date. It's quite tricky to use it as a way to kind of actively manage issues, to be able to use it to predict something. However, that doesn't say that it won't be useful in the future, and that there aren't things that we can do with that data to help us. One of the things we are looking at trying to use more is using drones for inspections, especially for locations where you might have a steep retaining wall with a cutting above, and you might have overhead, so it's always really difficult to actually get in to physically touch the slope. If we can use drones more to improve our understanding of those slopes, then I think that's probably the first place that I would look to having slightly more remote inspections, if you like.
And the last question, can you tell us a little bit more about long-term asset planning? What models do you have of asset degradation for future control periods? And that's from Peter Halliwell. Okay,
Peter. So this is definitely where I need STE, Simon Abbott's team to help. So I know that there are whole life models, whatever, looking at the whole portfolio and trying to understand, so I've got 50,000 assets that I'm managing. I might have 500 of them might be in E and 1,000 of them might be in D. I can't quite remember the proportion now. The bulk of them are going to be in A's, and then a mixture again between B's and C's. So you look at how, so you put some rules around it. Again, I'm using my hands, which is no good. So you put some rules around it. So you might say over the course of 10 years, a certain proportion of those A's might degrade to B's. and the B's into C's, etc. So you kind of try and work that out, and then you look at, okay, if you intervened on X number of assets in order to bring them from being a D or an E back to being a B or a C, for instance, by doing either refurbishment or renewal works. So you kind of think of that in the whole portfolio level. If you use this amount of money, how many of those degrading things could you kind of pull back? And it's those it's that way of modelling that the STE teams have done on our behalf to try and understand the level of investment we might need. Claire,
it's John Edgley here as well. I can't see who's on, so I'm assuming Simon isn't, which is a real shame.
I think he was, but I think he must have, he had to leave.
Okay, so if I can just add to your comments,
that'd be great, thank you.
So I definitely won't dive into any of the clever stuff in the science, but I can confirm that Simon and his team are really looking into this very intrusively. It was a subject to a conversation I had with him, and as it happens, Andrew Haynes a couple of weeks ago. So to have a good model, we can have a good statistical base and analysis, but the exam question that's live at the moment is, how do we improve our models? The advice, as I understand it, Simon has developing, I shall phrase, is actually where we need to put our money is on improved inspection techniques. So we talked about LiDAR earlier and drones and all that sort of stuff. So although the thought process is still in play, I think that is probably where we're going to be investing in more in the shorter term to get better data. And once we've started to gather that, then it's review those models themselves. So it's not a precise answer, forgive me. And I know Simon is, as I say, live working on that particular conundrum now. Okay.
Yeah.
Thank you. Also
thanks both of you.
Okay.
Hi there, I'm
Joe
Thorpe. I'm a PhD student at Loughborough University. I'm actually working with Simon on a PhD on earth flows and washouts specifically. So I know the university ourselves, we're trying to develop, or I'm trying to develop, sort of a model for sort of analysing sort of washouts and earth flows, sort of looking at the back catalogue of sort of failures against sort of the geology, superficial geology, permeability of the deposits, sort of local to the failures, and looking at kind of the hydrology in sort of a basin kind of scale. So this is something I'm only in month 2 of the PhD, but it's some of the things I've been doing already on sort of GIS are kind of showing some sort of promising kind of results at the moment.
Thank you.
Okay.
Excellent. Good luck with that.
Yeah.
In that case, then, can I ask David Godley now to propose a vote of thanks to Clare?
Thank you, Kevin. I think I'll put my camera on as well. I don't know if that'll or not, but I hope you can all hear me okay. Claire, it was a wonderful presentation, and you've come a long way from where Andy Savage and I were when, as civil engineers, we did our best, but we weren't great at it, and we had a little bit of expert support from some really good people in BR Research, but looking back, it was totally inadequate. And looking at how you approach it now, I really like the way you linked your slides to your team plan. I think, was it predict, prevent and respond? I can't remember. I've heard of predict, prevent, respond and detect before. So yeah, sorry, so you said?
Yeah, that's correct. Predict, prevent,
thank you.
respond.
Thank you, well done for that. And I know I've got a slide myself of Corby Tunnel, which I think was known as probably the wettest tunnel in the country. And every time we wanted a picture of something flooded, and we used to wheel it out. So those problems around Corby with drainage and earthworks are still challenging you, and certainly challenged us in the past. And I guess I'm glad there's so many people on the presentation as well, because I want all our young developing engineers to understand the challenge of managing earthworks, because anyone who's out on the railway will see it. You can't help but see it. You're always in a cutting or on an embankment or alongside a drain of some sort. And of course, your assets extend way beyond our line side boundaries. I know when we went up in the saloon a year and a half, 2 years ago now, on the far north lines in Scotland, it really was quite daunting to see the sea on one side of you with the railway going along the top of the beach, and then you look to your left and there's another kilometre of hill just going up. And you know, we've had problems all over on the Central Wales line, for example. So and you gave great examples today. We used to have the habit of calling some of these things an act of God, which of course is rubbish. You know, the places where the problems happen are often places where they've happened in the past, as you showed again in some of your slides. And we can't really go on relying on using words like extreme and exceptional weather. So the techniques you use, the georenim, the LiDAR, the systematic way you're approaching managing the earthworks, even breaking it down into your, I think you said, was it 5 chain, 100-metre lengths, and of course you can aggregate those back up to a full asset whenever you like, can't you? So, but it just feels a lot more professional than it was when we did it, and I'm really pleased that we have teams like your team and geotechnics teams across the whole of Network Rail who are dealing with it, because every time there's a problem, with the weather, there's a problem with the earthworks assets or geotechnical assets. So well done, thank you very much indeed.
Thank you.
I'll hand back to Kevin.
Thank you very much, David. On that note then, if Kate is happy over the management of the meeting, I'd like to thank all of you who are left for taking part in it, and those who aren't asked questions. Thank you again for that. And as per normal with the presentation, sometime in the next few days, this will be available online on the PWI website. And on that note, I'd like to thank you all and wish you a good weekend. Thank you very much.
Thank you. Bye.
Thank you, Claire. Thank you, Kevin.
Yeah, fantastic. Thank you.
Thank you very much indeed.
Many thanks, Claire.
Thank you, Claire. Very good.
Thanks.